GPS is essential to our modern world. It is imperative to us that we know exactly where we are in the world at all times, if only to figure out which street we need to turn on next. However, there was a time before this, a time when we had to use more analog methods of finding where we were in the world. But there was a time even before that where we didn't know how to find where we were. And that caused problems. And those problems took centuries to solve. And here we are, in the center of the northwestern hemisphere, to tell it. First of all, let's review the coordinate system that we use to map our world. Latitude measures where you are north to south in lines that go all the way around the globe, circles. Longitude is a different beast. Longitude measures where you are from east to west with lines that go only halfway around the world. Now, latitude is incredibly easy to find. All you do is you take something to measure an angle. A sextant, you're guessing, anything. And you measure your angle between you and the North Star, the camera's north. Or in the southern hemisphere, the Southern Cross. That is your longitude, your latitude. Screw it, keeping it in. Longitude, however, is different. When you're measuring longitude, you don't have any landmark like that, anything in the sky that doesn't move. And so you need to get a bit more creative. With this lack of solar landmarks to use to find longitude comes another one. Because the largest solar landmark on our planet is the sun. And there was one very simple thing that you could use to find longitude. Solar time. If you know the longitude of one place, say the port you're leaving, and you know the time there, and you also know the time where you are, then you can use that to figure out the longitude. It's an algebra equation. You need 3 to find the 4th. So that seems like a pretty simple realization. And in fact, we've known this for over 2,000 years, since the Greek philosopher, astronomer, I'm great at remembering my script. Hipparchus invented latitude and longitude. However, the problem was that we had no way to keep track of time. And we didn't have any way to keep track of times until the 1600s, when this started to become a problem. Large mechanical clocks started appearing in cities in the 1600s. However, these clocks were big and heavy, and you couldn't fit them on a ship. But there was another problem. Even if you could size down all of the components to take one of these clocks and put it on a ship, it wouldn't work at sea. The constant rocking of the boat would mess with the mechanics. And changes in humidity and temperature caused metal parts in these clocks to expand and contract, throwing them off or sometimes breaking them completely. So at the time, they didn't know of a way to solve these problems. And the focus turned to other methods of finding longitude. Latitude was solved very simply with an astronomical landmark. Could one of these landmarks do the same thing for finding time, and as such, for finding longitude? Finding longitude was a very, very important problem in science at the time. Europe was starting to spread its arms across the world and colonize the Americas, Africa, and And Asia, sure, and Asia. They were also going to Asia because spices, but whatever. Now, this meant that the greatest scientific minds of the time were focused on solving this problem, including a man known as Galileo Galilei, known today as simply Galileo. The astronomer had some ideas for finding time using what was in the sky. And he was very persistent. In 1610, Galileo was looking up in the night sky at Jupiter when he discovered 4 moons. He called these the Medicean stars, and he noticed a property of them that could be used to find longitude. These moons orbited around Jupiter in such a way that they were frequently eclipsed by the giant planet. Because of this, you could use them to find time. You see, they eclipse so frequently, about 1,000 times a year, or 3 times a day-ish, and so consistently that even in those times it was conceivable to come up with a chart that told you when these eclipses were going to happen and use it to tell you a set universal time. Galileo went right to work. Galileo was adamant that his method would work, and after some initial tests on land, it seemed promising. They worked. However, transferring the success to the sea proved to be another, more difficult matter entirely. Again, the problem is the constant motion of a ship. Jupiter is really far away, and because of this, it only takes a slight motion by the observer to throw his telescope completely away from the giant. The problems at sea did not deter Galileo, though. Galileo built a celotone, which basically was a special hat with a telescope in one eye and unobscured view in the other, so that you could look up and see Jupiter in the sky with your unguarded eye and then find it in your telescope. Eventually, Galileo conceded. Even with his special hat, on land, the user's heartbeat could throw Jupiter out of the telescope. It became clear to Galileo that the Medicean stars, or as we now call them, the Galilean satellites, were not the solution. But Galileo does not exit the story of longitude yet. With the failure of Galileo's method, focus slowly started to turn back to clocks. You see, before he died, Galileo had sketched out plans for a new kind of clock, known as the pendulum clock. Now, if you have a string, let's say, and you hang a weight from it, and then you start swinging it, you'd imagine that as it slowly slows down from friction and other forces, the time that it takes to swing back and forth would also go down because it has less distance to travel. However, that is not the case. The period of the wave doesn't change, only the magnitude, only how far it swings changes. The actual time does not. Legend has it that Galileo noticed this watching a lamp swing in church when he was a young boy after a monk had lit it. But that's a long time before Galileo died, so take it with a grain of salt. What we do know is that Galileo never built his pendulum clock. He died before he could. However, that didn't stop his son from doing it, nor did it stop another man who came up with the idea first. The first pendulum clock was actually constructed in 1656 by a man named Christian Huygens. this name, and we're gonna call him Chris, because Chris is just easier. So Chris constructed his clock in 1656, and he wasted no time proclaiming that this clock had solved the longitude problem. He quickly built 2 clocks that he proclaimed marine timekeepers and published a manuscript confirming these beliefs. And people responded, with his 2 marine timekeepers quickly being sent off on their maiden voyages. And initial testing was promising, with the clocks keeping time admirably. However, further testing proved that this was by no means foolproof. It showed that rough waters and changing climates quickly destroyed Chris's clock's accuracy. But Chris wasn't so easily deterred that his first clock idea failed, and he didn't call it quits. Instead, he kept innovating and came up with a second kind of clock that he believed would solve the longitude problem. Well, okay, maybe he came up with it. Chris's second idea was called the spring balance clock, and it used an oscillating spring to tell time. Chris patented this idea in France in 1675 without much difficulty. However, when he tried to apply for the patent in England, it was actually England. Great Britain didn't exist yet. I cannot stress this enough. So, when Chris tried to get the patent in England, he ran into problems because another man had also tried to patent the same idea. This led, and I forgot his name right now, so his name's going to be here. This led to a lengthy patent battle. However, for our purposes, it didn't matter. Neither man ever used the spring balance to create a marine timekeeper. However, with this patent battle, we've seen the exit of Chris from our story, and we've also reached a new century. By this point, by the beginning of this century, empires had begun to be forged. And so, the need for a solution to longitude was becoming more and more apparent. And this century also brought about one more man, the man who would finally solve the longitude problem. But that is a story for another time.